Welcome to the GDS Entry-Level Dynamic System Video Handbook. My name is Karl Snelling of GDS Instruments, and today I'd like to take you through the Entry-Level Dynamic System, the ELDYN, its individual components, and we'll learn how we're going to set the system up electrically, hydraulically, and how we run the software. The basic configuration of the ELDYN system, and the example I'm going to show you today, is made up of a triaxial cell. This one is a GDS 100mm triaxial cell for samples up to 100mm diameter, 200mm height. It has a dynamic upgrade, which is a linear bearing that holds the ram laterally stiff and reduces the friction doing the dynamic testing. The ELDYN load frame, which has the actuator at the top, the drives and the electronics in the base of the system. This is the ELDYN, or entry-level dynamic control system, the ELDCS. It's a 16-bit acquisition, high-speed data acquisition, 5 kHz, high-speed control, capable of up to 5 Hz for this system. And it's standard to supply this with an entry-level or a standard controller. Here we have an entry-level controller for the back pressure, and we've got one of our pneumatic controllers for the cell pressure. Unlike a traditional triaxial setup, a dynamic actuator moves very fast, and it certainly has the capability of moving very fast. So one of the most important aspects is safety when working with this piece of equipment. Of course, it has limit switches which will stop it at any time before it reaches any physical end stop. But in terms of working around the equipment, we must always have the stop button pressed. The stop button will stop any action of the actuator at any time. In fact, we thoroughly recommend, when setting up the triaxial cell, setting up the sample, or moving anywhere around the actuator, that you both have the stop button pressed and you turn the device off at the back of the machine. So let's connect the system up and get it running. We have a 25-pin to 25-pin male to female cable for the analog signals between the DCS box and the load frame, and we have a 9-pin to 9-pin male to female digital cable. There's only one way that these cables can be connected. 9-pin goes in the connector marked B, and the 25-pin, of course, goes in the 25-way socket marked A. Let's just get these in. These are then taken round to the back of the ELDYN machine. Just screw them up nice and tight, where the 9-pin and the 25-pin match the markings of A and B on the DCS unit and connect into the back of the load frame. Now we need to ensure we have power to both the load frame and to the DCS control box. So we have a normal IEC connector, which we will connect to the back of the DCS box. And I won't switch that on just yet. It runs from 110, 115 volts or 220, 240 volts. So you should have no problem there. And then the main load frame has a large connector for the power. Again, at 110 to 240 volts, which connects into the back. like so. The software should be installed first before connecting the DCS to the laptop, which we would use a USB lead. So I'm just going to connect the USB to the DCS control box, but I won't connect it to the laptop yet. Now we're going to connect up the transducers to the DCS unit. Now the channels are dedicated for particular transducers. Channel 0 is for a load cell because it has an input range of plus or minus 30 millivolts. Channel 1 and channel 2 both have an input range of plus or minus 200 millivolts, specifically designed for pressure transducers. Channel 3 has an input range of plus or minus 10 volts, specifically for the output of the pneumatic pressure controller, or alternatively for use with a potentiometric displacement transducer, which commonly has an output of plus or minus 5 or plus or minus 10 volts. In this system, I'm going to be using the output of the cell pressure controller because we don't have a displacement transducer. Not entirely necessary because we're going to measure the displacement using the encoder, the high accuracy encoder built into the actuator. So let's connect the load cell to channel 0 with its plus or minus 30 millivolt input range. The pressure transducer, this one I have an extension lead. The pressure transducer to channel 1. We're not going to have a secondary cell pressure transducer because I have a cell pressure output from the monitor of the pneumatic pressure controller. And the monitor cable has a 3-pin DIN and a 5-pin DIN. The 3-pin DIN goes in the front of the pneumatic pressure controller, and the 5-pin DIN is going to go into the 10-volt channel, channel 3.